How can drumlins be used to predict future glacial behavior? Have you ever wondered how scientists can forecast the behavior of glaciers in our polar regions? One fascinating tool they use is drumlins. These are streamlined hills formed beneath glaciers, primarily made of glacial till or other sediments shaped by the movement of ice. Their characteristics provide clues about how glaciers have acted in the past, which can help us understand their future behavior. Drumlins typically form in areas where the glacier's basal stress and thermal conditions reach critical levels. This usually occurs near the ice margin, just up glacier from the terminal moraine. Their presence indicates that the glacier was actively deforming and moving sediment at its base. This often happens during periods of ice advance or when basal temperatures are close to the melting point. Essentially, drumlins mark zones where significant sliding and sediment deformation occurred beneath the ice. The orientation of drumlins is particularly telling. They align parallel to the direction of ice flow, mapping out the former movement of glaciers. The shape of these hills can also indicate how fast the ice was flowing. For instance, larger drumlins or those that transition into megascale glacial lineations are often linked to fast-moving ice streams. By studying the fields of drumlins, scientists can reconstruct the patterns of ice movement and stress distribution during previous glacial periods. This reconstruction is essential for predicting how current glaciers might behave under similar conditions. If a glacier starts to show basal stress and temperature levels similar to those seen during drumlin formation, it could mean an increase in sliding and sediment deformation. This might lead to faster ice flow or shifts in glacier stability. Monitoring changes in drumlins or subglacial bed forms beneath modern ice sheets can serve as early indicators of shifts in glacier dynamics. For example, a transition from cold-based conditions, where the ice is frozen to the bed, to warm-based conditions, where the ice is at the melting point, can signal significant changes in glacier behavior. Understanding these dynamics is vital for predicting how glaciers will respond to climate change. It also helps in estimating how much ice sheets might contribute to rising sea levels. In the polar regions, drumlins are key geological features that record the interactions between ice and the terrain below. Studying them offers a glimpse into the past behavior of ice masses and serves as a tool to anticipate how these ice masses might change in the future as our climate evolves.